Hi, Professor.
How are you?
I'm good. How are you?
I'm good too. I'm good. I don't know what's happening. It's already 3:15, 15 minutes past the hour, and you are the only one in the collaborate session.
Mm-hmm.
Actually, there are in the discussion board. There are. Let me quickly check the discussion board again. Today's forum. Oh, geez, only 5 people in the discussion forum. I don't know what's happening with the rest of the class. This is very bad. Uh, by the way, did you receive the graded homework back?
Yes, I did. I received your email.
Okay, okay, good.
Yeah. Yes.
So, yeah, please read my comments and please, reflect those comments in the next homework in the homework
Yeah.
too, which is
It's due
due.
today, right?
Yeah, it's due today. Yeah, it's due
Okay.
today.
Yeah.
And one thing I need to, clarify is that um, in this class, there is no. It's not like F is below 60 is F or something like that.
Yeah.
In this class, is curved. It's curved, by according curved along normal distribution.
Hmm.
So what's important is where the mean of all these, scores.
Yeah.
And if you're above the mean, you're good, you're okay. And actually, it will have to be the grading will be determined by mean and standard deviation.
Repeat that.
So,
Sorry.
hmm, I'm sorry.
Could you just repeat like the last thing you said? It cut off.
Yeah, yeah, yeah. Your grade is determined by mean and the standard deviation of the
Uh-huh.
distribution.
Okay.
Okay?
Mm-hmm.
So, and one homework doesn't determine anything, as explained in the syllabus.
Yeah.
Um, there are 5 homeworks
Okay.
which count for 40%
Okay.
and of your grade, and so each homework is like 8%. And then
Okay.
midterm and final are 25-25, right?
Uh-huh.
25%, 25%. So that makes up 90%. And 10% comes from attendance and participation. So
Yeah.
even if, so 10% is like 10 points out of 100, but because I give participation points, those who have racked up a lot of participation points, they some of them have already reached 10 points because
Yeah.
due to the participation points. And so this kind of um, uh, this kind of boost, right? It gives the boost to if, for example, if your exam grades are not good, if your homework scores are not good, um, the participation points will cover, right?
Yeah.
Participation points will compensate for that. Also, as I said, it will depend on grading will be determined by the mean and the standard deviation of this distribution of your scores. So at the end of the semester, I
Uh-huh.
take the average, weighted average of your homeworks, midterm, final, and the attendance and participation points, and I will find the mean. I will also find the standard deviation, and based on that, uh, your grades will be determined. And if you're around the mean always gets the median grade. median grade is, B minus is the median grade, if you think about it.
Uh-huh.
Because, uh, so it's not like it cannot be determined by, simply the numerical score.
Yeah.
Okay, because obviously, if the test is very hard, the mean will be low, and if the test is very easy, the mean will be high. So there's no
Uh-huh.
way to norm the pass-fail point, pass-fail line at 60. There's no way it can be exactly put at 60. So it all depends. It all depends on the distribution. As I said, if the exams are very hard, the mean will be like 40, right? And if the mean
Yeah.
is 40, 60 is not a bad grade, right? 60 is not a bad score. 60 is a very good score, right?
Yeah.
And if on the other hand, if the mean is 80, that means uh, it's very the exams were very easy, and
Yeah.
the high 90 uh, score of 90 on a very easy exam where the mean is at 80, that 90 is still not a bad thing because it's above the mean, uh, but it's not that wonderful thing because that means on average everybody got 80. So it's
Yeah.
not a big deal, right? You understand?
Mhm.
So if the mean is very high, right, uh, uh, everybody gets something good, and that needs to be taken into consideration. So once again, there's
Uh-huh.
no preset level, right, to
Yeah.
tell pass or fail, or whether uh, 60 is not necessarily fail or anything like that. Okay, so you have to wait until the end of the semester to have the full um, compiled data, the fully compiled data to
Uh-huh.
find where the mean of the weighted average is and what will be the standard deviation of that. So for your information, the mean of the first homework was something like 35.
Uh-huh.
That is pretty low, of course.
Yeah.
35 is pretty, and it's because it includes not only the homeworks that were submitted, it's including everyone on the roster. So a lot of people didn't submit homework one. So for those who didn't submit homework one, they got zero, obviously. So it's the average. The mean is the mean including those zeros. So the mean
Mhm.
came out to be that low. So that goes without saying. Okay, but as I said, each homework is 8%. Right? Each homework is 8%.
Mhm.
Uh, this five homework makes up 40% of your grade. Okay, so that's something
Mhm.
just for your information. Okay. Now Hannah has
Mhm.
joined. How are you, Hannah? Hello. Are you there, Hannah?
I'm here. Hi.
Good. How are you?
I'm good. How are
Okay.
you?
Looks good. Good. Looks like your internet connection is good. That's what I can see here. And Jimena,
Mhm.
your connection seems pretty unstable. That's what I can see.
Yes.
Let
I'm
me
in
share my.
Indiana right now.
Oh, you're in Indiana. You're
Yeah.
visiting some family or relatives or friends or what?
No, it's for my dad's business trip.
Oh, okay. So
Hi. It's okay.
you're helping out your dad's business. You're helping your dad's business
Um,
or something.
yeah,
Oh, okay.
he had kind of like um it's like a dinner that they're giving him.
Oh,
So
oh,
he invited us.
okay. Oh, okay. All right. So hope you will stay safe. I mean, large gatherings are not, I hope that,
Yeah.
not the best place to be. Anyway, you can see, because I'm sharing my screen, that you can see
Mhm.
when I, let's see here, right? Oh, your
Uh-huh.
connection is good now. Back, it's green, right?
Mhm.
Hannah's good connection too. So let me go back to
When are we
where we. Mhm.
when are we gonna have our first exam?
Um, Pretty much, next week, next week, because
Oh.
normally, according to schedule, it would have to be uh, this weekend, but you just submit and we are already, like as I said, um, a week behind. We are like week behind. I mean, um, the the lecture is not behind, right? You understand? The lecture
Mhm.
is on schedule. It's just the review through the collaborate session. This is like a week behind. Okay, so if I go by only the lecture schedule, you can this weekend you can have the midterm, but just to be safe, because a lot of people seem to be also falling behind. I mean, they are not watching the videos as scheduled, but just try to rely on this collaborate session. So um, it's going to be like next week. And then the thing is, after next week, so you can see the calendar. Um, so think about it. Next week, we'll have to do it, early next week, not weekend. We'll have to do it early next week uh, because otherwise, we will have, uh, the last week is the week of the 16th, right? And we have, the last day is 19th. The final can be on the 20th, but there should be. So originally, it has to be like midterm should be this Friday. Uh, but let's see. I mean, how much difference will it make? And I want you to get the graded homework 2 back before the midterm. So I will need this weekend for grading. So it will have to be like early next week, right? The midterm will have to be like early next week. All righty. So so going back to where we were, we talked about uh, annuities last time, right? Especially we talked about future value of annuities, and I said um, it's not that difficult if you have a short timeline. If you have if you have just uh, like 5 years, and if the payment or deposit is just annual, it's not a big deal. We can do that. We can do it like this. But as I said, that's not gonna help us if more uh, more complex situations. So I told you to read this, and you must have read this already like a week ago. So let's take a look at this example. To prepare for graduate school in 5 years, you save $800 every month in an account with annual interest rate of 6%. So think about it. You want to make a deposit. You want to go to graduate school, and your timeline is 5 years. Since you're just freshman now, it will take 4 years to graduate with bachelor's, 4 to 5 years. If you graduate, if it takes 5 years, then um, fine. But if you graduate in 4 years, then with 1 year, you just, let's say you get a job and, get at least, 1 year job experience. Okay. And then apply for a graduate school and you get admission. So 5 years is your timeline. And to finance it, how would you pay for your graduate school? So you're thinking, well, if you have a part-time job, and if you save like $800 every month for the next, that's going to be how many months? Huh? For the next 5 years, it's going to be how many months? Jimena, how many months is that? Hmm? Are you there? How many months? How many months is it going to be? Oh, come on. Okay, Jimena, are you there? I can't proceed anymore because I was talking a lot and then everyone left, either because of poor connection or so it looks like everyone is coming in and going in and out. Are you there, Jimena?
Yes, I'm here.
Okay, so I lost you for a while, so I was asking you a question.
Hmm.
So did you hear my question?
No, I didn't.
Okay. But you heard this scenario, right? You're preparing for a graduate school, right?
Yeah.
And your timeline is 5 years. In other words, you will either graduate in 5 years or 4 years. But if you graduate in 4 years, maybe you work for 1 year, get raise extra cash, raise extra money uh, for the graduate school, and then go to graduate school in year 5, or anyway, if it takes 5 years for you to graduate from college with a bachelor's degree, fine. But the scenario is that you are going to pay for your graduate school. You're going to save $800 every month, right, for the next 5 years. And suppose you have a part-time job. So from your part-time pay, you can save $800 every month, right, for the next 5 years. But then how many months? How many months is it? How many months is it for? That was my question. Jimena, are you there? Hello,
Yes, I'm
Jimena?
here. Yes.
Okay, so how many months? How many months are you making these deposits? For how many months are you making these deposits?
60?
Yeah, 60. Yes, you're right. 60.
Mhm.
I'm afraid this doesn't, this doesn't merit, that extra points
Yeah,
because
yeah,
it's
yeah,
just
I
a
know.
very easy question. Um, yeah, so that means you're making, uh, $800 deposits, 60 of them, 60 of them. So if this is months, right, you will have your timeline will extend to 60, and every month at the end of the month you will uh, put deposit $800. Okay, so
Yes.
then our question is, if the APR is 6%, right? Will you have saved enough to pay for your graduate school in 5 years? And so our target future value, we know our target future value is 60K. That's what MBA program costs. I mean, CUNY, especially CUNY, being very affordable, CUNY MBA program for 2 years, it will be 60K would be pretty much, what it looks like. I mean, if it is Columbia or something like prestigious Ivy League schools, it would cost probably 60K a year. But CUNY, it would be half the price. So our question is, saving this way, in other words, 800 at the end of every month for the next 60 months, are we gonna reach the target future value of 60K? And how can you find out? I mean, first of all, not this one. First of all, making an 800 deposit for 60 months, simply, just thinking about just calculating those 800, right? The total of those, sum of all those 800 will be obviously, what will be this, all those, sum of all those $800? You're making 60 deposits. 48,000, yes, of course, 48,000. So obviously, with 48,000, you are still you're still 12,000 short of 60K. So you might say, oh, we can't, that's not possible. No, but you are forgetting about the interest, because we will be, the first 800 will earn interest. How many times? 59 times. 59 times, right? Second 800 will earn interest. How many times? 57 times, and so on. And the last 59th deposit will earn 6% interest at least once. Well, it's not 6%, first of all, annually 6%, but you are making monthly deposit, so you will need to make adjustment. You will need to adjust that annual 6% by 12, so that it would be monthly rate. But anyway, it's going to be then 59th deposit will earn interest one time at least, and the last deposit, it won't earn any interest, because it's going to be simply you're going to just the minute you dip it in, and then you take it out, right? So in a scenario like that, can we use such a diagram? Can you use such a diagram in a scenario like that?
Yeah.
Yeah, but what does that mean? Are you gonna draw the timeline and put like 60 notches like that, and then work all these numbers, 60 of them?
I mean, no, that would be a lot of work.
Right. Once again, it's not undoable. It's not clearly not undoable, but look, what's the point? I mean, that will be so tedious and so inefficient, right? That will be so tedious and so inefficient. So what do? Well, we'll have to use a reduced form formula. This formula is reduced form, right? I don't have time to, I don't have, after working out this problem, I'll show you how it is done, why, how we arrived at this reduced form. But, using this reduced form, right? That's what this is, that's what our exercise is all about. So take a look at this. And you have this file. You need to open this file in front of you. Do you have this file in front of you? Let me just check.
Yes.
You're the only one. What happened to You're the only one in the session. Hannah's not there. Christopher's not there. I don't know what they. So you need to have this file in front of you. Okay, you got it?
One moment. I'm just opening it up on my laptop.
Okay. Before starting this class, you should have these, accompanying files. I mean, for each topic, there are 2 accompanying files, one Excel file and one PDF file. You have to have them always ready before starting the class. I don't know where is everybody. I don't know where everybody is. It seems like I don't know. Okay, 8 people. All right, do you have it ready?
Yes, I am opening it up right now.
Hold on. Yeah, Hannah's back. Hannah, are you there? Hannah? It looks like your connection is strong, but your, internet connectivity. But it almost like loss of. I can see that 0% loss in audio and 0% loss in video. Where are you, Hannah? All right, so you're ready, right? Are you there?
Yes, I'm here.
Okay, good. Then, and if you have opened this file, then I want you to just clear out, delete all the highlighted cells. Delete all the highlighted cells, okay? Please delete all the highlighted cells. Okay, so everything is deleted. The highlighted cells are deleted. Are they deleted? Let me know. Let me know when you're ready. Ready now? Hello? Okay, you're lost again. Hannah, are you there, Hannah? Hannah? What's going on? Are you there, Jimena, now? Are you there?
Yes, I'm here.
Okay, for a while I lost you. So you have deleted the highlighted cells?
I'm deleting them right now.
I told you to delete it like 5 minutes ago before you were disconnected.
Yeah. Okay.
Okay. All righty. So if you look at row 2, right? Row 2, it's exactly our scenario. Think about it. Your deposit, I told you, deposit is the same thing as payment. Your deposit is $800. APR is 6%. Your timeline, 5 years. And your compounding frequency is 12, right? Because it's monthly. So first we find our periodic rate. And it's not a difficult thing. Our periodic rate is always, let's divide it by APR divided by M. And the actual number of compounding, because it is monthly over 5 years, there will be 60 compoundings, right? Or because 60 months, because it's 60 months. Okay, so T times M, right? 60. Now, we use this formula, right? We use this formula, future value of all those annuities. So, um, I'll have to open parentheses first. Payment times, open parenthesis, open the second, another parenthesis, right? Because although it is written as bracket here, in Excel, there's no difference between bracket and parenthesis. Okay, it's all parenthesis basically. So open the outer parenthesis and then inner parenthesis, 1 plus R raised to N minus 1, close parenthesis, divided by R. Okay? You're okay up to this point?
Yes.
Okay. And ready to hit enter? Hit enter. Okay, so this is the future value of all those $800 annuities. Okay? That means with the interest, right? With the interest compounding for every deposit, right? And the first deposit gets compounded, 59 times. You have to understand it very well that it is 59 the first deposit gets compounded 59 times, not 60 times, because the deposit is made at the end of the month, not at the beginning of the month, and that is called ordinary annuity, right? And we can also we can think about the that other scenario where the deposit is made at the beginning of each month, which is called annuity due. And the future value of annuity due, we can do it by compounding it one more time. Why? Let's take a look at the this one again. But before we go there, before we do that, let's think about it. So, is this good enough? Is this future value good enough? Jimena, is this good enough? No.
No.
It's not, because we need 60K, right? We need 60K because that's our target future value. That's what it costs for 2 years in MBA program. So then we try out a couple of scenarios. First of all, one thing we can think of is we can increase our monthly deposit, right? Monthly deposit by $50. And this thing, we don't have to work it out again. We can just drag it down, right? Because, the only difference is this. And, we are closer now. We are close, but, still about $700 short, right? Still $700 short. Well, our answer is not that far away. I mean, it's not that far, right? Maybe if we raise it to age 60, then we might get there, right? Just $10 more a month.
Yeah.
But also, let's think about, how about if we find a bank that pays 1% better interest rate? So let's say we found a bank that pays 7%. In that case, all we need to do is, okay, we just do the same thing again. Monthly, it's going to be, the periodic rate will be monthly. It's going to be like this, 0.58%, and it's still 60 months because, it's still 5 years. Okay. And then we don't have to do it again. We just drag it down and, we are still short. We are still about, $2,800 short, $2,700 short. How about then another scenario is, yeah, how about we postpone it by 1 year? If we postpone our plan by 1 year, then we're gonna go to graduate school in 6 years. I mean, so we extend our timeline by 1 year. Well, in that case, everything else is the same, but since time is 6 years, then it's going to be 72 months, 72 compoundings, and if you drag it down, we have we overshoot our target. I mean, we overshoot our target by $9,000, and with with $9,000, probably you can get a better apartment, or you can get a better, whatever. You can get a better health plan or health coverage, or you can get even a car, used car, and you don't have to live near campus. You can probably get a cheaper apartment in the suburb, and then drive to your. Of course, if you're going to CUNY, the car is not an option, right? Now, so wow, we found, pretty much, we found our what we need to do. We haven't nailed it yet, but we can nail it later. But to reach our target future value, we know $800 is not enough, but it should be something greater than $850. We can nail it later. But what about what if we use annuity due? Okay, remember, annuity due is when deposit or payment is made at the beginning of each time period, right? So it's like this. So if you think about it, what is the difference between ordinary annuity and annuity due? I mean, this diagram is, I just borrowed this diagram from somewhere, so they don't have the same number. But assume that they have the same deposit, same interest rate. They have same deposit, same interest rate. But then what is the only difference? Jimena, are you still there? Jimena?
Yes, I'm still here.
Okay, you're there. Hannah, are you there, Hannah? Hannah? What's happening with Hannah? Hannah's connection is quite robust. I can see that like this. And Hannah's connection is even better than yours, Jimena. But she's nowhere to be found. Okay, so the question is, so what do you see? What is the difference? What is the difference between, and I told you, assume all the numbers are the same. Monthly deposit is the same, right? So assume they are the same, 1,000. Interest rate the same, but what is the difference? What is the real difference between the two? Do you see this? I mean, if you can answer that, if you can see this, this is 1 extra point question.
So it's not the interest rate, right?
No. Assume the interest rates are the same, monthly payments are the same. You just, they're all the same. But from the pattern, what do you see? What's the difference?
Um, they're they're all raised to a different power.
So you said, say it again. What did you say?
They're
They
all raised
operate
to a
at?
different power.
Oh, they're all raised to different power. Actually, uh, they are raised to, I mean, uh, yes, that's true. You are close. But you can say, look, the first deposit, is raised to a fifth power. This in the annuity due, it's raised to fifth power, right? And but in ordinary annuity, it's raised to fourth power. I mean, the first deposit, uh, this one in annuity due, it has one more power, right? One more, raised to one more power. Second one too, right? This is ordinary annuity. It's raised to the third power. It's raised to the fourth power. Third power, right? It's only squared. No, squared. It's just one, right? And the last deposit, this one earns interest at least once. This one earns no interest. So you are very close. The only difference between the two is that, you can say, annuity due has one more compounding. Every term in annuity due has one more compounding, right? Does that make sense? So the only difference between, in other words, if you multiply, if you do one more compounding to, um, ordinary annuity, right? The result of the ordinary annuity, then that's going to be the result of future value of annuity due. Okay? So anyway, Jimena, yeah, you really noticed, you notice something that's really, crucial. Um, Jimena, uh, I'll give you 0.75 for that because that's, you didn't exactly describe it in a nutshell, but you got the concept, you got the correct idea. Today is what, 0805. Okay, you got 0.5 extra point for that. Yes, so that gives us an idea. Oh, that means we can recycle the result of the ordinary annuity. And that means, because future annuity due has one more compounding than ordinary annuity, all you need to do is really literally give it one more compounding, right? One more compounding. And you see, and then that's what you get. You can drag it down. There you are. Of course, you are still, when you make 850 deposit, you are still closer, but still about $400 short. But we can exactly nail it, and that's what we are going to be talking about now. So, okay. So did you all get the same result as mine? Did you all get the same result?
Yes.
Okay, good. So now let me talk about the. So how did that get to be this? How did the formula get to be this? So let me. So now let's think about it. So basically, annuity, future value of annuity is we can think of, okay. First of all, it is $800 every month. That's deposit, but the symbol for that is payment, PMT, payment. And I've been telling you, payment and deposit are two sides of the same coin. So the first deposit will get 1 plus R raised to n minus 1. Okay, and in our example, n is 60, right? In our example, R is 0.05 or 5%, 0.5%, 0.005, of course, 0.005, right? Because 6% divided by 12 is 0.5%, so 0.005, and n is 60, right?
Yeah.
And the second deposit, yeah, right, you got it. And the second deposit will earn interest. It will earn it 1 plus R, that's the interest rate, 1 plus R raised to n minus 2. Okay. And then we'll keep going like this, right? Then the next one will be n minus 3, n minus 4, and then we go to next one. The last one is actually last deposit earns no interest, isn't that right? But the one before the last one, it will earn interest once, right? And the one before that, so that's 1, right? We don't have to write 1, right? But so this is the 59th deposit, right? This is the 59th deposit. Last deposit, 60th deposit doesn't earn any interest, which will be so there's nothing, but it's still consistent to write it this way, just to show you. It earns no interest, so 1 plus R raised to 0. And why did I do that? Now, you remember, anything raised to 0 is what? Anything raised to 0, we talk about this. Yeah, 1. It's 1. So, yeah, that's what it is. So we write it, but we don't have to. Eventually, it turns right. It turns to just payment, right? Okay. So let's call this equation. So I'm trying to show you how this long polynomial. You understand what polynomial is? Polynomial is, this 60 terms. I mean, I have 60 terms of this many terms, right? And so I'm trying to show you how this is, reduced to that, right? So if you call it, equation 1, now let me do this. Let me multiply equation 1. Let me multiply equation 1 by 1 plus R. Maybe I should use, rather than, okay, equation 1 times So in other words, I'm going to multiply 1 plus all to 1 plus r to everything in equation 1. So if you do that, then the whole thing, you have to do that to both right-hand side and left-hand side, because it's an equation. Whatever you do to the left-hand side, you must do to the right-hand side, right? Whatever you do to the right-hand side, you must also do that to the left-hand side. So if you do that, the left-hand side will be 1 plus r times FVA, future value of annuity. And the right-hand side will be, here, then it's going to be payment. And what is this going to be? Are you there, Jimena?
Yes, I'm here.
Okay, so then what is this going to be? Payment time, yeah, it's 1 plus r raised to n minus 1, and you are multiplying that by 1 plus r. So what should it be? What's it going to be?
1 plus 0.5.
0.5? No.
Oh.
It's 1 plus r. We're not even, we're not putting that, a number in there. All I'm saying is if we multiply 1 plus r to this, right? If you multiply 1 plus r to this, right? What's it going to be? Think about it. What is this n minus 1? What is this n minus 1?
59.
59. So you multiply 1 plus r raised to n minus 1, 1 plus r to the 59. If you multiply that by another 1 plus r, what should it become?
1.
No, why does it become 1?
I don't know. I was kind of confused.
Only if you cancel, if it will become 1 only if you multiply it by 1 over 1 plus r. But you are multiplying. Think about it. It's 1 plus r raised to the 59. Isn't that right? 1 plus r raised to 59. So you multiply 1 plus r there. 1 more 1 plus r. So what does that become? Jimena, think about this. We have 10 cubed, right? 10 to the third power.
Oh, okay.
We all know it is 1,000, but if we just express it 10 to the third, you multiply another 10. What should it become? It shouldn't be that difficult. What should it become?
10 to the 6th.
Why is it 10 to the 6th out of blue?
Oh, I was just adding it.
Yeah, but how do you add it? You add what?
The 3s.
What 3s? There's only one 3. Look, I'm not doing 10 to the third times 10 to the third. I'm just doing 10 to the third times 10.
Oh.
What is it?
Yeah.
differently. You know, what is 10 to the third?
Well, that would equal just 10,000, I think.
Yes, it's 10,000. But what is, because this is 1,000, 1,000 times 10, then 10,000. And what is 10,000? In power of 10. In powers of 10, what is 10,000? If 1,000 is 10 to the third, what is 10,000?
Um, 10,
10 is just
10
this,
to
isn't
the
it right?
fourth. Oh, wait, 10 to the fourth?
10 to the fourth, of course. I mean, does it take that? Is it that think about it. It's 1,000 times 10, and 1,000 is 10 times 10 times 10, right?
Mm-hmm.
1,000 is 10 times 10 times 10. That's the meaning of 10 to the third. And 10 times, so
Mm-hmm.
10 times 10 times 10 times 10 is 10 to the
Mm-hmm.
fourth. What else is it? Also by the rule of x to a times x to b. I mean, you saw this, right? The rule of exponents, x
Yeah.
to plus b, right? And even by that,
Mm-hmm.
it's the same thing, right? So then think about it.
Mm-hmm.
My question was, it was originally 1 plus r raised to n minus 1. 1 plus r raised to n minus 1, right? And then you multiply it by
Mm-hmm.
another 1 plus r. So what does it become?
Um, n minus 2.
No, why? You are multiplying another 1 plus r. How can it go down by another 1? Huh? Remember, it was this n minus 1 was 59, wasn't it?
Yeah.
N minus 1 was 51. So you multiply that by another 1 plus r, and what should it be? Does it go down to 58?
Yeah.
What do you mean? Yeah, we just did that. Think about it. Suppose this was 10 to the 59. I mean, this is a very simple. Suppose this was 10 to the 59th. You multiply it by another 10. What should it become then?
10 to the 59.
No.
It'd
This is
be
59. So, huh? This is 10 to the 59th, then you multiply it by another 10. Then what should it become? Jimena, when it was 10 to the third and you multiplied by 10 and it was 10 to the fourth, and if it is 10 to the 59th, you multiply by 10, what does it become? What should it become?
uh, do you want it like solved? It would be 60.
Yeah, of course. It would have to be 10 to the 60. Right? 10 to the 60th power. It should be. I mean, what is so difficult about it? 59, it's 10 to the 59, you multiply it by another 10. Then it should be 10 to the 60. Right? Is it so difficult? And think about it. Then this was 1 plus r raised to n minus 1, right? So you multiply it by another 1 plus r. You multiply it by another 1 plus r. What does it become?
1 plus r to the 60.
Yes, but 1 plus r to the 60. But 60 is our example. 60 is something given in our example. But in general, what should it be? In general, what do we call it? I mean, it's not always 60 in every problem, right? Why do we use something like n minus 1?
Mm-hmm.
It's to make it, generic, right? So if
Yeah.
we had r raised to n minus 1, so you multiply by another 1 plus r, then what should it be? What does it become? Ah,
1 plus r to the second power. Sure.
what second power? I mean, second power. Second power is just 1 plus r times 1 plus r. But don't forget, this is n
N to
minus
the
1.
second.
I didn't write it because I will have to erase it later. You understand? If n minus 1 was 59, then by
Yeah.
multiplying by 1 it becomes 60. Then what is 60? Do you understand what I'm talking about? I didn't want to do this because I will have to erase it again later, and it's not easy to write it like this.
Mm-hmm.
I've been telling you because I'm drawing it with the mouse, and then just to
Mm-hmm.
erase it. Do you want me to do this just to erase? But think about it. If it is 1 plus r raised to n minus 1 times 1 plus r, right? Then what should it be? I mean, do we leave it like this? Do we write it like this?
Um.
I don't understand why. Look, n minus 1 was 59. I'm even writing it here, and you can't make that connection. You can't see that. N minus 1 was 59. Then what should be 60?
6 and minus.
It is just n then. If n minus 1 is 59, then you give it another 1 plus r, then it will become n. You understand?
Mm-hmm.
So that's why I've been saying
Yeah.
that I didn't write it here because I will have to eventually anyway. If I write it like that, if I write it there, then I will have to anyway erase it later, right? So think about it. This is 59. This is 58. You understand? Then 1 plus r raised to n minus 3 would be 57, and so on. It keeps on going like that. So then until it goes all the way down to r 1 plus r raised to 2, 1 plus r raised to n. But then 1 plus r raised to 2 will be what? N minus 57. I mean 58, right? And 1 plus r raised to
Mm-hmm.
1 will be n minus 59, right? This is n minus, this one will be payment times 1 plus r raised to n minus 60. So that will be 0, and then, it will be only payment. Okay? Uh, all righty. So then, uh, okay, I hear you have a little puppy there, and it's yelping. payment. It's not PMT. Oh, God, it's so hard. So then what does this become? Because you understand, we are multiplying everything by another 1 plus r. So that's what it means, right? I said I'm doing, because this is equation 1, and to equation 1, I'm multiplying equation 1 by 1 plus r. That means what? So everything gets raised by another 1 plus r. This one is raised by 1 plus r. Left-hand side is multiplied by 1 plus r. That's like being raised by 1 plus r. This first term is raised to n, so it went up by 1 plus r. So what does the second term become? What does this become? Jimena, are you there?
N to the second.
Yeah, but what does this become? N to the second? What do you mean? What is n to the second? 1 plus r to something. N is not the base. N is the exponent. So if this gets, this will get raised by another 1 plus r. So what does this become then? I don't know why you are, you can't follow. I don't know why you don't understand, or you can't follow this. Look, isn't it just mechanical? If this became what? N minus 1 became what? N minus 1 became what?
Mm-hmm.
That's not an answer. I asked you, N minus 1 became what? And you say, That's not an answer. That's only yes or no, right? That answer is yes or no. But the question was, N minus 1 became what? What did it become? Then you should say, it's not yes or no question. Do you understand?
N minus 1 became n.
Yeah, N minus 1 became N. Okay, why can't you, give a sensible answer like that? And then what does this become? In equation 1, what was N minus 1? What does it become in equation 2?
N minus 2 becomes n minus 1.
Yes. You got it right. And then, although it is omitted, or although it is not shown in equation 1, but there must have been payment times 1 plus r raised to n minus 3, right? There must have been that. But then that term raised to n minus 3, what would that become in equation 2? Huh?
N minus 2.
Yeah, you can tell it's going to be, in equation 2, because it's raised by another 1 plus r. It becomes n minus 2, right? And if we keep going like this, you can tell that this term will become, so everything goes up by 1. Everything goes up by 1. It will become payment times. But this thing becomes
I'm sorry.
raised to. No problem. If I had that puppy in front of me, I would like to squeeze, hug it, almost.
I'm trying. I don't know why she's crying.
Yeah, that's okay. I mean, fortunately or unfortunately, right? There's only you in this class. I mean, let me just check. Hannah was there, but she's almost inactive, and you're the only one. So It doesn't bother anybody else. Okay. So you see, so by multiplying it by 1 plus r, we know now. So yeah, what I'm saying is I want to cuddle it like, squeezing it. Okay, so this term becomes payment times 1 plus r squared, and this term becomes payment times 1 plus r. That makes sense? Right?
Yes.
Okay.
Yeah.
So call this equation 2, right? Let's call this equation 2. And with equation 1 and 2, what am I going to do? I'm going to subtract equation 1 from equation 2. Okay, I'm going to subtract 1 from 2. Then what's it going to become? In other words, well, you might wonder, oh, you're subtracting something above by something, you're subtracting something below by something above. Yeah, I mean, just it may not seem very usual because normally you would put this down here, but it's already written there. I cannot bring it down here, right? I will have to rewrite it, and it's gonna take a lot of time. So just use your brain. In other words, mentally, we are subtracting this, right? We are subtracting this. So that means everything here, everything in equation 1 will change sign. You understand? Does that make sense? Everything will be minus. Isn't that right? Because we are subtracting. Does that make sense?
Yeah.
Yeah, everything in equation 1 is minus because we are subtracting. So it's minus FVA, right? Minus payment 1. So everything here is negative. They will all change sign to negative, right? Then think about it. That means this one is negative, this one is positive, this one is negative, this one is positive. So what happens? This one and this one cancel out, right? What about this? This one and this one will cancel out. Everything in between, all the intervening terms will cancel out. There is, payment times, it's not shown, but there is certainly payment times 1 plus r squared. And that is minus, that's negative, so it gets canceled out. What about this? This too. Because this is negative, this is positive, they cancel out. So then, what are we left with? Finally, we will be left with, then, here, it's 1 plus r FVA and minus FVA. So we can factor out FVA. You understand? Do I have to write it?
Yeah.
But this is wrong. Oh, so let me rewrite it. So in the left-hand side, it's going to be 1 plus r FVA minus FVA here. And on the right-hand side is payment times 1 plus r raised to n all the way there, minus payment, right? That is the only thing that's left. And it's negative because, it was subtracted, minus payment. Okay, now we can simplify it by factoring out a common factor. Here, common factor in the left-hand side is FVA, right? So it's going to be 1 plus r. We factor out FVA, so this term will be 1 plus r, and factor out FVA, so this term will be -1, right? So hard to write with. It's so hard to write with the mouse. And on the right hand, in the right hand side, is going to be we factor out payment. If we factor out payment, it's going to be 1 plus r raised to n minus 1. Right? You got it? And then we know this 1 and -1 will cancel out each other, right? 1 and -1 cancel out each other, right? And then we're left with, then, are you there?
Yes, I'm here.
Okay, so you got that, right? 1 and -1, they cancel out. So we are left with FVA times R. And on the right-hand side, it's going to be payment times the thing in the bracket. I'll just call it the thing in the bracket, okay? Because it's so difficult to write. Now, and what is our unknown? What are we trying to solve for here? What is our unknown? Why did we do all of this? Jimena, why did we do this? What is our goal? What are we solving for? What is the unknown that we are solving for here?
FVA.
Yes, it's FVA, right? So then remember, I've been telling you, all equations can be reduced and must be reduced to z equals x times y format, right? So that we can then, we can solve for x, we can solve for y, we can solve for z. Isn't it right? Right? You remember that? And do you see z equals x times y structure here? Do you see z equals x times y structure here?
Yeah.
Yeah. So then which one is z? And which one is z? Which one is x? Which one is y?
Z is FVA.
No. That's what we are trying to solve for. So how can it be z? This whole thing is z, right? This whole thing is z, and this is x, this is y. You understand?
Okay.
Because we are trying to solve for this. Isn't it right?
Yeah.
Then, okay, so then FVA will be then, what's it going to be? So what is FVA then? Are you there, Jimena? Hello? Hannah, are you there, Hannah? Hannah? Can you hear me, Hannah? Can you raise your hand? Maybe.
I'm back.
Oh, hi, Jimena. Okay, I'm trying to check with Hannah. Because it might be her microphone. Maybe she's saying something, but I don't know. Okay, so Jimena, did you hear my question? So What is FVA then? How do you
Would it
solve for FVA? Huh?
would it be payment over FBA?
No, we are solving for FVA. What are you talking about? Payment over FVA? I
Oh,
mean, FVA is the left-hand side, and FVA is here again on the right-hand side.
yeah, no. So, payment over 1 plus R?
No, there's no 1 plus R. Where do you see 1 plus R?
I'm looking at the top equation.
No, no, no. Here, look at this.
Hmm.
Are you looking at this?
Yes.
Yeah. Then, what is, if FVA is X, what is Y? This is Y. This
R.
is Z. So what should it
R.
be? No, yeah, yeah. So give me the whole thing. Give me the full sentence.
FBA equals R times payment.
R times. What are you talking about?
Parentheses.
What parentheses?
I'm looking
If
at
you
the
have
brackets.
identified, huh? If you have identified Z equals X times
No,
Y
nothing.
structure, what should be X? If you have identified this structure, then X is simply Z over Y, isn't that right? And I've shown you what is Z, what is Y, and why can't you do that?
Z is payment.
Only, yeah. So give me the full sentence. Don't just say, don't give me, just piece by piece. Give me the whole thing.
Payment over R.
Yes, but okay, it's not just payment. It's payment times. It's payment times what? It's the thing
Payment
in the bracket, right? Payment times the thing in the bracket. But what is the thing in the bracket? What's the thing in
1
the
plus R.
bracket? Okay, 1 plus R. Is that all? 1 plus
1 plus
R.
R to the n.
Yeah, 1 plus R to the n. And is that all?
Minus 1.
Minus 1. And you should close the bracket. So the thing in the bracket is this. So it's payment times 1 plus R raised to n minus 1, then over R. Okay? So we arrived here. Right? We arrived here. And compare it with the formula I gave you. Look at that formula. Do you see it there?
Yeah.
This formula is exactly, we derived that formula, right? We derived that formula, right? From the original definition of annuity, from the original definition of future value of annuity. You understand? So this is how this formula came about. Because most of the textbooks, wherever, you learn this here and there, even accounting classes trying to teach some, this. But they use table instead of, really, working out the math. They use table. And then they don't explain how this formula came about. That's the difference. This is how economists and financial economists do things. Okay, we don't just use the end result, final result. without understanding how that end result came about. You must first understand and know how that end result was generated. Otherwise, we never take it as given because it needs to be verified. Is this the correct formula? I mean, do we take it? Of course, most of the times it will be the correct formula, but knowing why it is so is very important, right? So this is the formula we have used. Another thing. So remember, so I'm gonna have to. Okay. Remember, we also. Okay, let me go back here. We tried different scenarios, right? With different tactics, right? We tried out 850. We tried out 7%. We tried out 6 years, but uh, we fell short of our target future value, right? But I said, can we? And we were close. We were very close when we uh, uh, used 850 as input as the monthly deposit, right? So I said it would be about 860. I mean, if we try 860, we might get there. But so we can try putting in 860, or then we may get it, or we may exactly nail it or not. Most likely we won't exactly nail it. But then what do? We try something slightly less than. If you're closer, then we try something either greater or slightly less than 860. But then again, doing this, how long will it take? How many times, how many times do we have to try out different numbers? It's called, trial and error method, trial and error, right? Eventually you will get it, but the trial and error method is inefficient, isn't it right? Because we never know how many trials it will take, right, to nail the exact number. And it's also called iterative method because we are iterating, right? Iterating the same process over and over. But then iterative method or trial and error method, they basically mean the same thing. It's inefficient, right? And we may nail it exactly someday, but we never know how long it's gonna take and whether we will exactly nail it or not. So then the question is, instead of using trial and error method, why can't we just solve directly for payment? Yes, we can do that, right? Don't you think?
Yeah.
Are you there?
Yes, I'm here.
Okay, right. Thank you. Because I can't see, when I'm looking at Excel, I cannot see what's going on in the blackboard. So think about it. Yeah, we can. Remember, we are here, right? We derived formula all the way to this, but before there we were here, right? Remember that. So from this, think about it. We can, if payment is because we want to know the payment, right? Exact payment. We want to know the exact payment. And actually, so this is X. Payment is the X. Isn't that right? Payment is our X. And this one is known. Isn't future value known? Yeah, actually, our future value is known because we have the target future value. Right?
Mm-hmm.
What is our target
Yeah.
future value? 60K. We know that, right? We know that.
60K.
Yeah, it's known. And interest rate is also known, right? That's not APR, but monthly rate.
6%.
It's known too, right? It's 0.5%, right?
Yeah.
So the left-hand side is known, right? And in the right-hand side, payment is unknown. That's the only unknown. But we know R, right? We know R. R is known.
Mm-hmm.
N is known, right? R is 0.5%, N is 60. So everything in the thing in the bracket is also known. Isn't that right? The thing in the bracket is also known, right?
Yeah.
In other words, Y is known. Z, and think about it. Then because payment is the unknown and the left-hand side is known, this time this left-hand side is the Z, isn't it right? The left-hand
Yes.
side is Z. Okay, but again, okay, uh, let me derive further, right? So what would you say? Oh, to solve for payment, then what would you do? If payment is the unknown, right? To solve for payment, what do you do? And this time payment is Z. So what do you do? Tell me, what do you do?
Divide.
Divide what by what? What is Z?
The future.
No. Don't give me words. I've been telling you, we don't use words. We speak in math. So payment is X, so what do we need to do? What is Z? If payment is X, obviously to find X, we need to do Z divided by Y. So what is Z?
Z is 6K times 0.5.
No. Don't give me numbers. There's no need. Just give me the logic. Give me the algebra.
Um,
So what is Z?
is it 3,000?
Don't give me the number. I told you,
Z.
number is meaningless because
FBA.
yes, give me that.
FBA times R.
Yes. And, and then what? What is Y? X is Z divided by Y. So what is Y?
Wait, I can't hear you very well.
What is Y?
Y is 1 plus R to the N.
Y is the thing in the bracket. The thing in the bracket is 1 plus R. What? Raised to N, right? Are you there, Jimena?
Mm-hmm. Yes, I'm here.
Okay, so it's 1 plus R raised to N minus 1. Isn't that right?
Yes.
Okay, so then this is the formula for payment. So then we can nail the payment. Isn't that right? We can nail the exact payment. So
Yes.
that way, so here, I gave you the formula for payment. look at that. Compare that with this. That's exactly this. Isn't it right?
Yes, it is.
Right. That's exactly that. Right? And some students even say, there are some students who say, well, professor, then that in that formula, the payment of FVA is, separate. Look, it's the same thing. Whether, I mean, when you multiply something to a fraction, basically it is multiplied to only to the numerator, right? So it's the same thing, isn't it right? It's the same thing,
Yeah.
right? So using that formula, what time is it? Okay. Using that formula, we can do this. Okay, I'm gonna using that formula. Finally, and of course, I want you to do this with me. Don't. So we want to nail the payment. Of course, to do that, and since we know the future value, right, already, target future value. This is, what did I do? Divide it. 0.5%. And this one is, of course, 60. Okay. Then, using that formula, right? Using that formula here, FVA. Okay. So, equals future value, right? Times R over, right? Open parenthesis, open another one, 1 plus R raised to N minus 1, close parenthesis. Okay? Are you good all the way to this point? Jimena,
Yes,
are you good all the way? Okay, then if we hit enter, and you will see. There you go. Right? There you go. 815. I told you, if we try out 860, we will probably hit our target future value, right? But we don't know. I mean, if we tried out 860, we would have overshot it slightly. We would have overshot our target slightly, right? But now with this, we exactly nail the monthly deposit that will take us to, right? Exactly to 60K, which is our target future value. So what are the rest of them? What are the rest of the rest of? Okay, the rest of it is basically there's nothing, of course. Finding interest rate in annuity and finding n, right? Because this is finding time, finding n. So here we will. This is actually this should be since we don't have time. I will simply okay. Since we don't have time, I will simply point to the form. I will give you the formula. First of all, there is no single unique formula. There's no single unique formula to find R in annuities, right? So basically, it requires iterative or trial and error method, right? But of course, we can't. We can't because of the inefficiency of trial and error method. We don't use that. Instead, we can use Excel's Excel's built-in function. Okay, so I normally don't teach Excel's built-in function because students just use it without thinking, right? But there's no other way. For rate in annuity problem, you have to use Excel's built-in function. So if you click on function there, right? Did you see what I do? Did you see
Yes.
what I do? Okay, you can open it from there or also from formula, and then um, what is listed here is most recently used. So you want to go to financial, right? And if you go to financial, and all the financial functions are there, and the 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 variable we are looking for is rate. So you scroll down because it's in alphabetical order. Uh, you scroll down until you find rate, and then hit OK. All right, then you have to get and asking for, first of all, n periods. N period, that means that's n periods, right? So you give it n, which is there, right? 60,
Mm-hmm.
and then payment. Payment is this one right here, but be careful. When you enter payment, you must make it negative. You must make it negative. Why? I'm going to explain that later because it's the cash inflow, cash outflow thing. Uh, this is cash outflow, so you have to make it negative. That's what needs to be done on a financial calculator. You make, and there's no present value because this is not a single cash flow model. There is no present value, so you leave it blank, and then uh, future value. You enter that there, and type means either uh, annuity due or ordinary annuity. The default is ordinary annuity. So unless otherwise specified, we assume ordinary annuity. So if it is ordinary annuity, you leave it as a blank. You leave it blank or enter 0. Okay? So blank or 0, that's the same thing. If it is annuity due, you enter 1. But think about it. Why, if it is annuity due, why do we enter 1? You remember what's the difference between ordinary annuity and annuity due? You remember? We did this. What is the difference?
Yes.
You nailed it, actually.
The
You nailed it.
exponents change.
Yeah.
Yes.
How does it change? There's
It's
just
always
one more
one less.
compounding. One more
Mm-hmm.
compounding. What do you mean one less? Huh? Annuity due has one more compounding than ordinary annuity, right?
Yeah.
One more
That's what I meant.
compounding.
Sorry.
You said one less, then that's totally a different thing. That's all. So
Yeah.
that's why you enter 1. If it is exact annuity, you enter 1. If it is ordinary annuity, you leave it blank or enter 0. That's it. Nothing more to do. Then you already have something showing here, 0.005. And that's our answer. I mean, we already know it's 0.5%, right? So
Mm-hmm.
that checks out. Our formula checks out already. So the minute you do that, we got 0.5. And then here, then, because that is, monthly rate, we know it is monthly rate, right? Because M is 12. And to convert it into annual, what do you do? Because it is monthly rate, to convert it back to annual rate, what do you need to do?
Multiply.
Multiply that by what? Multiply that by
12.
Yes. Don't say 12. Multiply that by M or
By M.
D8.
Yes.
Yeah. Okay. And it will give you 6. Okay. There you go. We got that. We nailed it. Next is obviously, then the unknown is N. right? Unknown is n, right?
Mm-hmm.
So how do you solve for n? I gave you the formula here. Oh, I gave the formula for present value of annuity, but for future value of annuity, I gave the formula here. If you go to yeah, here's n. How you solve for n? For future value of annuity, the formula is this: n natural log of future value over payment times r plus 1 over natural log of 1 plus r. Yeah, a lot of times, even in single cash flow model, uh, we have to use natural log, and in the denominator, it was always natural log of 1 plus r. So we're going to enter that exactly there. Okay, I'm going to enter that exactly there. So it's going to be natural log of, it doesn't have to be capital. You don't have to capitalize it. And what was the formula? Natural log of f fee over payment times r. So okay, our f fee is here in G9. I'll have to type in G9 because our formula has expanded. That cell has expanded and is uh, covering that G9. So I'll have to just enter in manually over payment. Okay, the whole thing times R, and that's okay because this is not going to be multiplied to the denominator. It's going to be multiplied to the whole thing, or just the numerator. Times R plus 1 close parenthesis, divided by natural log of 1 plus R. And it should give us 60, right? And the formula checks out. You're okay up to this?
Yeah.
Jimena, you're okay. Then you hit enter. Hit enter, and yeah, you get 60. Did you get 60? Okay.
Yes, I got 60.
If you convert that, that's 60. That's what, 60 months. So if we convert it into years, what do you do? If you convert it into year, what do you do?
You multiply times m.
No. If you multiply this by, this is n.
Oh. You divide it.
So yeah, you divided that by what?
M.
Divided by m, and there you go. 5 years exactly. Okay. Alrighty. So that's it for today. We don't have, we already, I get no break, but
Yeah,
you've
no,
been
it's
the only
fine.
student today, and homework 2 is due today. I mean, actually, we couldn't cover the lecture covered already. The review couldn't cover present value of annuities, but you are supposed to have already, studied it by, the lecture videos already, so you should be able to do that. There was no way we could review the similar problems, but you should be able to do homework too. Okay. Alrighty, Jimena. So that's it. I will see you tomorrow. I mean, no, next Monday. Tomorrow is Friday, so I'll see you next Monday. And so please be safe, stay safe, and I will See you on Monday. Okay, signing out.